matemáticas de Jansen y Kendro.
Pero no es una joda!
Chicas, hora!
So that was a new introduction. We love Mrs. P. All right, on to math. 6.1, roots and radical expressions. Okay. When you read the directions, you have to be very cognizant. Ooh, that's a big word.
Is that Spanish?
Well, it's a new language anyway. Of the directions, because if it says all, it's different than if it says each down there at the bottom. All means you have to be careful of plus and minus showing up. If it says each, real number, they're just asking for the positive answer. So we'll be careful and be sure we mention that lots of times. So we get rid of some of these little cute boxes here. Come on, baby.
Maybe.
There we go. So find all the real square roots. So if we take the square root of 144, it can be 12 or negative 12. You have to think, what's 12 times 12? Negative 12 times negative 12. They both get 144. Okay, now let's move over to the cube roots. Cube roots, we're still finding all, but they act a little differently because there's three numbers, so there'll be three signs to deal with. Cube root of 8 is 2 because 2 times 2 times 2 is positive 8.
Wait, do you need a positive and negative on this one?
Well, let's think about that. What if I had negative 2 times negative 2 times negative 2? What would it be?
That would be negative 8.
So that doesn't work because we want positive 8. So in this case, the negatives are not included.
So how can I remember this? When we did square roots, we needed to do a positive or a negative, and when we do cube roots, there's only one answer.
Well, because there are an even amount of numbers here.
Okay.
If you have a square root or a fourth root or a sixth root, all the even roots would give you a plus or minus.
Okay.
Odd roots, you only have what is given. So in this one, the answer is negative 3 because negative 3 times negative 3 times negative 3 is negative 27. A fraction, you can split the fraction up, or you can think of just doing each one individually. What's a cube root of 1?
1.
Cube root of 64?
4.
4. And it's positive, so we keep it positive.
All right. What about fourth roots?
Fourth roots are even, and you have to think to yourself, we have 4 numbers here. 1, 2, 3, 4. Fourth root. So what times what times what times what is 81?
Oh, I know 9 times 9, so couldn't it be a bunch of 3s?
Yeah, 9 times 9, and if I break each of those up into 3s, I'll have 4 of them. So it's 3 times 3 times 3 times 3. So the answer is just 3, but remember it's even. Fourth root is even, so you have to put in your plus or minus.
Is there a button on the calculator that could help me with this?
Yes, it looks like this.
Oh, with the little X.
Yeah, so
Okay.
you put the 4 in, then you hit that button, and then you put whatever number in there.
Awesome.
All right.
Okay, now we're doing each root. So each root instead of all.
So each is just your clue that we're only doing the positive. So it's just, what is the square root of 49? It's 7.
Okay, not plus or minus.
All right, this one.
We got a little extra stuff going on here.
Yeah, we got some negatives happening. So this negative out here, we're just going to leave alone for a minute. The one underneath, what's the cube root of negative 8? We actually did one up here of positive 8. So cube root of negative 8 is negative 2. And then this negative out front will just hang out in there until it's needed at the end. Now we have negative times a negative, which is a positive.
All right. Moving on. Maybe. There we go. All right, now we're going to simplify. We're going to throw some variables in there eventually. This is the square root of 8. So this is something that is not a perfect square. So remember that how we talked about doing this, we looked for the largest perfect square that you can divide that thing by.
Wait, isn't it 2? Are we doing cube root here?
Nope, this is square root, and I know that because there's no number there. That's
Oh,
actually called the
yeah.
index. There's no index written, so therefore square root is implied.
Gotcha.
Okay? But if you were to try that in the calculator, or hopefully you know that 8 is not a perfect square. So I want to split it into the largest perfect square, so I would do 4 and 2. The square root of 4 is 2, so 2 root 2 is the simplified version.
Nice.
Okay? Let's do another one just for review before we throw the variables in. So 48. Okay, some of you might be tempted by like 6 and 8, but that's not a perfect square.
4 and 12. 4 is 1, but is there a bigger one?
I think there is. I think 16.
16 times 3.
Yep, so you want to do it that way. 16 and 3. That helps me because I know the square root of 16, it's 4. So 4 root 3 is the answer. I want to show you though, what did you tell me? You said 4 and 12?
4 and 12.
You know, when you're doing that, hopefully you notice that 12 could be split into 4 and 3 again. So if you can keep going, you need to find something that's bigger.
So to save yourself work, you pick the biggest
Right.
one to start.
Technically, this could work out if you noticed that, and then you take the square root of both of these guys. But I'm worried about us being able to do that.
Yeah.
Okay.
Plus, mathematicians are lazy, remember?
Yeah.
Got the biggest one.
Okay, so let's throw some variables in there.
Woohoo.
We did put a little note in there. It says the book will ask you about absolute values. You can ignore this. So
Yay.
anytime they'll say something about use absolute values when necessary, or they might say assume all the variables are positive. You can ignore that. So, okay, here we go. Square root of 4, and then it's x to the 6. So the first thing that we would like you to do is to split up the numbers and the variables. So we'll work with them separately. So square root of 4, that's easy. We know that. That's 2. Okay? When we do our x to the 6, what I'm going to do just to start, I'm going to write them out, and then we'll show you the shortcut later.
Looks like a bunch of kisses.
Like those hugs. No, you're right. Kisses.
Kisses.
And then hugs
O's are
the
hugs.
O's. Okay. So what we're going to look for here, because I know there's no number there, but this is really a square root, that means that we're looking for groups of 2. So I have one group of 2, second group of 2, third group of 2. Every time you get a group of 2, it's like it's a ticket out of the radical. So having this group means an x gets to come out, having this group means another x gets to come out, and having this group means another one, and there is nothing trapped inside.
Lucky x's.
Okay, simplified, this is 2x to the third. Now, there is a faster way to do this. What do you notice about this number and this number?
They're half of each other.
That's right, and that's because of the index. So you can try to just kind of do it in your head and say how many groups of, for instance, in this example, it's how many groups of 2 can you get out of there? So
or you can just take 6 and divide it by 2.
Exactly. Right.
Okay, cool.
But sometimes they don't end up coming out evenly. We'll get there someday. Here's another one. So this one's cubes. So we're going to split it up. Cube root of negative 27, and then cube root of c to the 6th. So cube root of negative 27, that is the kind that you keep the sign, so it's just going to be negative 3. And then c to the 6th, this time I'm looking for groups of 3, or, like you said, we could do 6 divided by 3. You should get 2 groups, so that means negative 3c squared. If you have trouble doing that, write out all the list. And then circle groups of 3. There's 2 of them.
Look like half of hugs. We have full kisses and half hugs.
All right, moving on. All right,
groups of 4.
Yes, groups of 4. So, or take the exponent and divide it. See, there's no number, so we could just say 4 divided by 4, that's going to get me x to the first on the outside. And then 12 divided by 4 is y to the third.
Nice, that's easy.
Yeah, and this is, you're starting to hopefully see that it's a lot easier to do the division than have to write out 12 y's and circle them. Okay, last one. So square root of 36. Split that up, square root of x to the 36th. Well, this is just 6. And then remember, you're not square rooting this, you're dividing it by 2. That's going to give us 18 x's. So we definitely don't want to have to write out 36 x's and circle them.
Right, that'd be a lot.
Right. I call that the square root method.
Okay, here we go. So we have another example here. This is set up a little bit differently, but because the left side is squared and you want to solve, we're going to square root both sides. We're going to do our square root method that we learned in previous chapters. When you do the square root method, it's the same as taking or finding all answers. Square root of 25 is 5, but because 5 or negative 5 would work for the x, we have to include both.
Okay, so when we square root both sides, it's even, so that's why we need plus and minus.
Right on.
Okay.
Okay, x to the fourth. The fourth root of 16 is 2. The fourth root of 625 is 5. But because it's even, we need to put in our plus or minus.
So you're just rooting both sides to get rid of that exponent.
Right on.
All right.
We got to the root of the problem here, folks.
And learn some Spanish.
Absolutely. Es obvio.
And I don't know what less is. Then una hora.
That's right.
Hora.
Hey, we'll see you tomorrow.